Hello and welcome! Today, we're going to explore a powerful scientific technique called atomic fluorescence spectroscopy, often shortened to AFS. It's a method scientists use to find out which elements are present in a sample and, more importantly, how much of each element is there. AFS is incredibly sensitive, which means it can detect even the tiniest trace amounts of an element, making it vital for things like environmental safety and food quality testing. The whole process works in three main steps: atomization, excitation, and detection. First, we have to prepare our sample in a process called atomization. We take our sample, which is usually a liquid, and turn it into a very fine mist. This mist is then passed through an extremely hot flame or a heated graphite tube. This intense heat does something crucial: it breaks apart all the chemical bonds and evaporates the liquid, leaving us with a cloud of individual, free-floating atoms of the element we want to measure. The second step is excitation. Now that we have our cloud of free atoms, we shine a beam of light on them. This isn't just any light, it's a specific wavelength, or color, that we know our target atoms love to absorb. When an atom in the cloud absorbs this light energy, one of its electrons gets a boost and jumps to a higher energy level. The atom is now in an excited state. But atoms can't stay excited forever. This leads us to the third and final step, detection. Very quickly, the excited atom wants to relax and go back to its normal, stable state. To do this, it releases the extra energy it absorbed. It releases this energy in the form of light, which is called fluorescence. This fluorescent light shines out in all directions. Here's the clever part: we place a light detector at a 90-degree angle to the path of the original light source. By doing this, the detector avoids the bright initial light and only measures the faint fluorescent light coming from the atoms. The brightness of this fluorescence is directly related to the number of atoms in the sample. More glow means a higher concentration of the element. This makes AFS extremely specific and sensitive, perfect for detecting toxic metals like mercury, lead, and arsenic in our water, soil, and food. Thank you so much for watching and learning about atomic fluorescence spectroscopy with us. If you found this explanation clear and helpful, please show your appreciation by liking this video and subscribing to the channel. Your support helps us create more content to make science simple and accessible for everyone.